Hi, boys and girls, and welcome back to Multiplying Decimals. We are going to be looking at, of course, patterns and connections between numbers, as always, because we're multiplying. We will use precision or attend to precision, which means, yes, we should check our work the best way that we can with the strategies that we have. And we're going to use the appropriate tools strategically. You're going to have to choose which model is best for the type of problem that you're using. And then we will model that. We're going to show our thinking. So our goal is to use the area model and partial product, which is part of the standard algorithm, to multiply decimals. And our goal is to be right here. Now, what's important is that you understand in order to begin this lesson or to reach a 3 on the scale, you must be able to multiply two-digit whole numbers using the standard algorithm. You must be able to successfully multiply numbers like this. Can you multiply 24 times 52 using the standard algorithm? Do you know how to do that? You also need to be able to use the strategy for basic multiplication. So if I ask you, okay, do you know how to multiply 6 times 8? Do you know that it's 48? Do you have the mental math or other strategies to do that? If you do, then you're ready for this lesson. So there are two ways, as we stated in the scale, to multiply using decimals. We can use the area model or we can use partial products. Now, partial products means we're going to see parts of the product. And remember, the product is the answer to a multiplication expression. So this is the product. These are the two factors. There could even be more. I don't want to limit you to just two. No matter how many factors you have, the answer is called the product. So let's take a look at the area model, and you might be surprised and remember this from 4th grade. When we use the area model, we're looking at the place value in the numbers, and we're first going to write this expression in expanded form. So I have 10 plus 2. Wait, where did you get the 10 from? Remember how we write numbers in expanded form? What is 12 written in expanded form? It is 10 plus 2. Now we're going to write our second number in expanded form, and it is a 10th plus 9 hundredths. All we're doing is separating or breaking out the number, and we're writing it based on its place value. Now I'm going to erase my area model here just because I didn't leave myself enough room to write the numbers clearly. So here is my area model. Now that I've broken out the numbers, I'm going to write these numbers on the left side, and I'm going to write these numbers on the top. So 10 and 2 go here. 1/10 and 9 hundredths go here. And now I'm going to multiply. 10 times a tenth is 1. Notice where I'm multiplying these two numbers and then this number. Then I'm going to say a tenth times 2 is 2/10. And then 9 hundredths times 10 is 9/10. Notice I had to move the decimal point because I'm multiplying by 10. So I had to move the decimal point one time to the right. And now 9/10 times 2 is 18 hundredths. Now I'm going to take all of these numbers and add them up. So I have 1, and I'm going to use these two zeros as my placeholders. Then I have 9 tenths, Miss Addison, I can put a 0 here as a placeholder. I have 18 hundredths, and then I have 2 tenths, and I'm going to put a placeholder. Remember from previous lessons, decimals like to dance together. They don't like to be apart. So make sure when we're adding and subtracting our decimals that we line the decimals up, because they do not like to dance alone, honey. Okay? Now I'm going to add all of my numbers, and I have 2 and 28 hundredths. Easy peasy, right? Well, there's another way, and I'm sure you'll like that better. 1 and 54 hundredths times 23. Notice how I'm lining up my decimals. When we're multiplying using the standard algorithm, you're going to freak out, but don't. When we're multiplying, we kind of ignore the decimal point to set up our multiplication problem. Okay? And we solve it just like you did in 4th grade. So 4 times 3 is 12. 5 times 3 is 15. Plus 1 is 16. 3 times 1 is 3, plus 1 is 4. Ignore the decimal point for now. Pretend it doesn't even exist. Then I'm going to multiply again. 2 times 4 is good, 8. 2 times 5 is 10. Regroup. And 2 times 1 is 2, plus 1 is 3. And now I'm going to add all these numbers. Ignore the decimal point for now. I'll show you how to place it in a moment. So now we have 4 digits, 3, 5, 4, and 2. Notice that these are called partial products. That's where that word comes from. Partial products are parts of the product. Now, the part of the product is not really 462 and 300, but these are partial products. These are partial products. I need to place a decimal point. How many digits are on the right side of the decimal? We have 5 and 4. So that makes 2 places that are to the right of the decimal. 23 doesn't have any. 20 whole well, because there are 2 tires to the right of the decimal. And 42 hundredths. You might be like, wait, what? No, really, that's exactly how it's done. Let's do another one. And actually, I'm going to have you try this one with me. So let's set up our problem, and let me make a note for you. The area model is best used when you're multiplying a decimal times a whole number. If you're multiplying 2 decimals, it's actually a lot better just to use the partial products or the standard algorithm. Let me say that again. When you're multiplying by a whole number, it is best to use the area model, or you can use the standard algorithm. When you're multiplying by 2 decimals, like let's say this was 4.2 times 2.12, it's best to use the standard algorithm, which is the same thing as partial products. Okay? That's a little nugget that'll help you forever. So first we're going to write our problem in expanded form so that we can see how to create our area model. Remember, these numbers go on the left side. These numbers go at the top. And then we're going to multiply. So 2 tenths times 20 is 4. Because I'm moving, I'm going to multiply the 2's, and then I'm going to move my decimal once to the right because this is a multiple of 10. We're multiplying by 20. So the answer is 4. And then 2 tenths times 3 is 6 tenths. 5 times 20, or 500ths times 20 is 1. Now, don't freak out about that. Ask yourself, if I had a nickel, because this 500th is the same thing as thinking about it like a nickel. If I had 20 nickels, how much money would I have? Exactly. I would have $1, or we would say 1. And then 500ths times 3 is 1500ths. Think about it this way. 5 nickels times 3. If I had 3 nickels, how much money would I have? I'd have 15 cents or 1500ths. Thinking about these numbers like money is extremely helpful. Now, you'll notice, why did you put a 0 there? I'm using those zeros as a placeholder so that it's easier for me to line up my decimals to add the numbers. Remember, we line up the decimals. Decimals like to dance together when we're doing addition and subtraction. Wait, what did she say? Right. The decimals dancing together is for addition and subtraction. Okay, now we're going to use the standard algorithm. You can put the decimal there to remind yourself of what numbers we're multiplying by. However, when you multiply, ignore the decimal at first. And if I'm sorry if I didn't mention that. We have 5 and 7500 for the area model problem that we just did. Now we're going to use the standard algorithm. You could pause the video and multiply, and for the sake of time, I'm going to do that now. Okay, these are my partial products, and here, now it's time for me to place the decimal. 1, 2. There are 2 places in the expression that are to the right of the decimal point. 1, 2. Our answer is, or our product is 89 4/100ths. Now it's time for you to solve these 2 problems on your own, then come back and check your answers. Okay, boys and girls, check your answers. You should have 13 1200ths for the first one and 90 9300ths for the second number. Now, one of the questions I often get is, what do I do if I have 2 decimals? How do I determine how to move the decimal point? I'll show you. Okay, boys and girls, here's a sample problem, and you're probably thinking, oh, well, this looks similar, but let's look at placing the decimal point. We have 1, 2, 3, 4 places behind the decimal. So we're going to count 1, 2, 3, 4 places and place the decimal point here. That means that we have 0.6835, or you could say 6,835 10,000ths. That's difficult to say. Now, some of you might be wondering, okay, how did we end up with a smaller number? When we multiply decimals by each other, we end up with a smaller number. So a whole number times a decimal is often larger, but a decimal times a decimal, because we're multiplying parts of a part, is usually going to be smaller, okay? So here we have 0.6835, and the same rule applies. There were 4 places behind the decimal point, so there should be 4 places behind the decimal point. All right, thanks for watching. Remember to go back and see if you got this problem correct, and then use that to place where you are on your scale. Until next time.